Got another amplifier on the bench today. Today we have a Fender Princeton Reverb amplifier. And what we are doing with this one is we have a request to convert the 2-prong cord to a 3-prong cord. And this amplifier is not one that sits in a house or sits there unused. This is a working amp. And the person who uses it plugs it in when they go out to do jobs. And, you know, sometimes depending on how the quality of the electrical wiring or the situation of the environment, they seem to get shocked by the amplifier, and they would very much like this to be grounded. And I am going to do that today in this video, so let's get started. First thing I'm going to do is pull the actual amplifier from the cabinet and put the cabinet somewhere safe. Good, now we're ready to pull the top screws and remove the amplifier from the unit. The top brackets have now been removed. The unit can now be taken apart. And the cabinet can now be put somewhere safe where I won't damage it. Probably a really good idea. There we go. This is what we're left with. There's really not much amplifier after you take away the cabinet. Before you decide to flip it over like this, it's generally a good idea to have a good stand set up. I have 2 wooden boxes that I know will clear the tallest item on the amplifier, having worked on several of these. So I just put them on the ends and be able to flip it over, and it gives me access to the top. And yeah, I'm nosy, so even though I'm not working on this amplifier for the purpose of repairs, I want to see what's in here, what kind of work has been done on it. I could see that on the cathode bias capacitors, you can see them all throughout here. They're tied in parallel to these resistors. You can see at some point they have all been replaced. They don't look original to me. I see also down here at the bias circuit here, this is the rectified voltage for the negative bias. Also a kind of a shoddy looking potentiometer there to set that. That doesn't look original to it. That's a Bourne's potentiometer that was soldered in place, but that capacitor does not look original to it either. It looks almost like one of them European capacitors too. And you can see the diode way back there. So some work has been done there. On these smaller Fender amplifiers, it doesn't have the metal cage with the separate filter capacitors, right? You can see that it's in fact a 4-in-1 multi-can capacitor here, right? And it's a 420s rated at 450. This one shows a Mallory FP. This may in fact be original to the amplifier. If not, it's probably very old, made in the USA, right? These capacitors and coupling capacitors and what have you look original to the amplifier. These ones that are that red or burgundy color right here. And I see all of the resistors here. I don't see any real work done there. On to business, of course. We can see the line cord coming in is the 2-wire variety. And we got hot and neutral. And it is going into this auxiliary jack, this plug. And if you look on the other side of this, and I'll flip it over later as it becomes relevant, you'll see that the neutral and hot are tied to 2 different size prongs on there. They make their way to the this switch, which has different names depending on the amplifier. They call it on this one the ground switch, the hum switch, whatever have you, right? And it also has the death cap is hidden down there. It's way down there. You really can't see it, right? And then the fuse ties off to this, the power switch, and then the other side makes its way to the transformer, obviously. And that's the power circuit, and that's where we're going to be making our modifications to this amp. Okay, let's get this party started. There we go. No way back now. Using great care, I've managed to reuse the original cable stress relief, which holds this cable very tightly. I've given myself enough cable to work and then just a little bit more, right? So we are good to continue. Here's a part of the project that requires great care, and it is the scoring of the shielding of this cable without cutting into the wire. If you cut into the wire, it's game over. You got to take it out, pull some back through, and try it again, because you can't risk a fire or a short circuit. I have a razor that I use. It's a little blunted. It's not very sharp. And I just use that to score this very carefully. Very carefully, a good score was done. None of the inner insulation was damaged. So now I can remove this outer shielding. Now that the shielding's been stripped, the first wire that I'll be starting with is the ground wire. And I'm going to have to solder an eyelet onto this wire. I had a choice here between blue and red flavor. And I had found that in looking at the gauge of the green and the size of the screw here, that it turns out, it just happens to be, that red is a better fit. It's a tighter fit on the screw, right? You see, it just fits very nicely. And also, as far as the gauge goes, it's smaller than the blue. It's more appropriate sized for this wire. So we're going to go with red. We're not done yet, though. We're going to hit this with some lead, let it flow in there, give it a nice solid connection. Heat it till it flows. There we go. I like to add the heat shrink only because it looks a lot nicer than those connectors, so just put a little heat shrink on there just to clean this up a bit. Nice. Because there's a ground, I'm going to hit this right quick with a little deoxit on both the nut and the screw and the mating surface, just to get any grime off right quick. Nothing crazy, you know, just clean it up. This portion job is now complete. This amp is totally grounded forever. Let's do a quick continuity test from the ground post here to the chassis. Looking good. We're going to get started by cleaning up this power receptacle, remove all these old wires, install the new ones. This right here is the little connector, and it will get the black wire. Big connector gets the white. Terminals are all cleaned up. The wire is stripped. I've dressed up everything really nice, and they're all through. Now we'll add some new cables to replace the shorter yellow cables. They're not long enough to reach where they have to go. There we go. Now we'll just solder them in. So now everything is soldered and dressed in, and we are ready for the next step. So then I removed all of the yellow wires that were connected to the ground switch one at a time. They all came off, and once that was done, I simply twisted the black and white wires that I had installed and then reconnected them. The black one going to the end of the fuse, the white one going to the switch to complete the original circuit, obviously without the ground switch in the middle. Because the death cap is connected to the center of the ground switch, I could leave it in because the death cap effectively is no longer in the circuit. This switch is touching nothing. It's perfectly safe. It's just there for show at this point. I did take a piece of the old wire and tie this slack back over here just so it doesn't get caught when I reinstall it in the amplifier. That was it. Other than that, this installation is completed. We're now going to run a quick test. Got the multimeter connected through the two prongs of the electrical cord, and then I'm just going to flip the power switch for the amp over here on and off. Then what I'm going to do as an added measure, of course, is just with each one touch ground. Make sure that there's no short to ground. That one is good. Do the other one. That one is good. And then as a final test, of course, circling back to the beginning, I'm going to touch ground and touch this. Confirm ground is good. We're done with our test. We can reassemble the amplifier. Now everything is back together. I have it connected through the variac and the isolation transformer. So what I'm going to do is apply power directly to the amplifier. Then we're gonna fire it up, make sure everything's okay. 200 milliamps at 60. Yeah, we're looking good. No cause for concern. About 300 milliamps here at idle as we come up. 66 watts, 600 milliamps. Everything appears fine. No hum, no hiss. So this concludes the 2-prong to 3-prong plug conversion for the Fender Princeton Reverb amplifier. Thanks for watching.